Okay, we're looking at lesson 8-2, the reciprocal function family. And we know that functions that model inverse variation, that was from lesson 8-1, have the form of f of x equals a over x, where x is not equal to 0. So x cannot equal to 0 and make it undefined. They belong to the family whose parent is the reciprocal function, and it looks like f of x equals 1 over x, where x, again, cannot equal 0. Transformations of the parent reciprocal function include stretches, compressions or shrinks, reflections, and horizontal and vertical translations. So when they're speaking of stretches, they're talking about things that go closer and closer. Shrinks are things that are going away. Reflection is to flip it to the other side. And horizontal and vertical translations is to move it up or to move it down. The general form of a member of the reciprocal function family is y equal a over x minus y plus k, where x cannot equal h. And the reason that it cannot equal h is because if it equals h, that means it's 0. And we can't have 0 in the denominator. So the inverse variation function, y equals a over x, are stretches, shrinks, and reflections of the parent function, reciprocal function, depending on the value of a. So the graph of the parent reciprocal function y equal 1 over x is shown at the right. So this is the parent function. This is the function that all of these functions come from. So we can change it, we can manipulate it by stretching it, shrinking it, reflecting it, or translating it. All right, so let's take a look at problem number 1. It says graphing an inverse variation function. So it says, what is the graph y equals 8 over x? X cannot equal to 0. Identify the x and y intercepts and the asymptotes of the graph. Also state the domain and the range of the function. So they went and they did tables, they plotted points. But I'm going to use my free graphing calculator at www.desmos.com. And I'm just going to say y equals 8 divided by x. And there is my function. I'm going to have to zoom in so that we can see it a little bit better there. So here's my function. Y equals 8 over x. Okay? And oops, wrong book. And I can actually make a chart for my Desmos. So let's do that. I'm going to add a chart. I'm going to convert this to a chart. And here we have our chart. And I wanted to make this chart in particularly because I wanted you all to see that at 0 is undefined. So x cannot equal 0. So x equals 0 makes it undefined. So that also, we can also look at our graph and I can see that it doesn't cross the x-axis. It gets closer and closer to it, as you can see, but it doesn't cross it. And it doesn't cross the y-axis. Okay? So, going back to my book, they just went through and connected the points. And so, we look at it, the x-axis has to be the horizontal asymptote because it's the place where, as you can see here, that it gets closer to, but it doesn't touch because it can't touch it. It can't equal 0. And the x-axis is also the horizontal asymptote. So x is the horizontal asymptote and y is the vertical asymptote. And knowing the asymptotes provides you with the basic shape of the graph. So I know that I'm just going to get closer and closer to the y, and closer and closer to x. So, and notice that the values are going to get smaller and smaller. I can actually put my values in so you can see. So notice it's getting closer and closer to 0, but never actually reaching 0. So notice the more I go, I can just keep going and going and going, and it doesn't get to 0. Okay, so it's going to get closer and closer to 0, but it doesn't reach it. Okay, and so the domain, which is what are all the values that the x can be? Well, the domain can be all real numbers except x equal to 0. So it can't be x equal to 0. We can't have x equal to 0 because we see up here at x equals 0 is undefined. And the y is the same. I can't have it at y equals 0. So the range is the set of all, because there's no way that I can make it equal 0. There's nothing that I can plug in for for x to make y equals 0. There's no number that's going to make y equals 0 for my function y equals 8 over x. I can't do anything to make it 0. So that's why it can be all values except y equals 0. So that's my range. All right, so let's take a look at the guide. It says, what is the graph of y equals 12 over x? Let's graph that. So I have way too much here. Y equals, let's do y 1 because I already have a y, equals 12 over x. And there. So you see, it's just it's going a little bit away, so it is shrinking away. Did you see that it's shrinking away from my y-axis, shrinking away? And let's see, what else do they ask me? It says identify the x and the y intercepts. And as you can see, there aren't any x or y intercepts just like the first one. And it says also state the domain and range. And you can probably guess that the domain and range are the same. So it's all, for the domain, it's all real values of x except for x equal to 0. And for the range, it's all real values of y except for all real values except for y equal to 0. So it can be any number. And we can make a chart again. Oops. There we go. And again, we see a 0 is undefined. Okay, so it says reasoning. Would the function y equals 6 over x have the same domain and range as y equals 8 over x and 12 over x? It certainly would, because again, you can see it's the same type of idea. We know that x cannot equal 0. We know that if x cannot equal 0, y cannot equal 0. We also know because it's a because of the function family that it's from, that those asymptotes are probably going to be the x-axis and the y-axis. I hope this helps.